Alright guys, so I am going to go over the study guide for the Unit 1 test. The first problem says find the solution, and it is an order of operations problem. So I'm actually going to rewrite it off to the side so that I make sure I have enough room. But when I rewrite it, I need to make sure that I rewrite it correctly because that could mess me up. So I see that we have grouping symbols, and I know that grouping symbols or parentheses are always what we do first in the order of operations. So I'm going to do my little upside down triangle. 4 plus 3 is 7. And since I solved what was inside the parentheses, I don't actually need to bring the parentheses down, so I'm just going to bring down the rest of the problem. And here I have multiplication and subtraction, so I know I have to do multiplication before I do subtraction, and 7 times 7 is 49. I bring down the minus 3, and 49 minus 3 is 46. So my answer is 46. All right, let's look at number 2. Another order of operations problem. So here we have brackets and parentheses. So we have to remember what to do when we have two sets of grouping symbols. So I'm just going to begin this problem on a piece of paper because I don't have quite enough room to do it, and I would encourage you to do the same thing when you have your test. So I'm going to rewrite the problem, but I'm going to make sure that I rewrite it exactly as it is on my paper. Okay, and that is all there. Okay, so when we have brackets and we have parentheses inside the brackets, we always have to work from the inside out when we have two pairs of grouping symbols. So inside out. So we're going to start with the 8 minus 4, and 8 minus 4 is 4. And since I solved what was inside the parentheses, I don't need to bring them down, but I do need to bring down my brackets. And then I'll bring down my plus 6, and so now I'm left with this. We still have grouping symbols, so I know that that comes first. 3 times 4 is 12, and then I bring down my plus 6. Notice I didn't bring down my brackets again because I know that since I solved what was inside the brackets and there's nothing left to solve, I don't need to bring them down. So now I have 12 plus 6, and my answer is 18. Okay, so I'm just going to transfer that up here to my study guide. Answer is 18. All right. So now we can look at number 3. Solve 35 times 38. Just move this over a bit. Okay. 35 times 38. So I'm going to do this in two different ways. I'm going to use the box method, and then I will use partial products as well. So I'm just going to grab another piece of paper because I don't have quite enough room to do it on my study guide. So I'm going to do it on here. All right, so when I use the box method, I'm going to make a pretty big box so that you can see. Cut it into 4 pieces. Then when I expand my numbers, I turn 35 into 30 and 5, and then I turn 38 into 30 and 8, and then I multiply 30 and 30 together. I get 900. 30 times 5 is 150. 30 times 8 is 240, and 8 times 5 is 40. So then I'm going to add all those numbers up, making sure that I line my numbers up properly. And then I add them up. So 0, then I have 4 plus 5 is 9, and then 9 plus 4 is 13. Carry my 1. 9 plus 1 is 10. 10 plus 2 is 12, and then plus 1 is 13. So my end answer is 1,330. And so I'm going to do partial products real quick if that's the method that you like to use. So in that case, I would line up my factors here, And then I would look at 8 times 5. Then I would do 8 times 30. I would do 30 times 5. And 30 times 30. Here I would get 40. Here I would get 240. Here I would get 150. And here I would get 900. And as you can see, you end up adding together the same numbers. So when you add them together, you end up with 1,330. So same answer, just two different ways to do it. All right, so I'm going to transfer my answer up here to my study guide. And there we go. All right, next problem. Okay, so this question says part of Kim's solution for 63 times 92 is shown below. So she did partial products. So she started with 60 times 90, then she went to 60 times 2, 3 times 90, and then we need to know what comes next. So I like to set it up like I were going to solve it as if it were partial products. And I look at the numbers that I'm working with here. We have 2 times 3, 2 times 60, 90 times 3, and then 90 times 60. And then I'm just going to match up what she already has. So she already has 90 times 60. She has 60 times 2. She has 3 times 90, and the only one left is 2 times 3. So I know that that has to be her next step in solving that equation. All right. Let's go on to number 5. All right. So another multiplication problem. So I'm going to set this up. I'm just going to do area model this time. And it does seem like I have enough room on my paper to do it, so I'm just going to do it right on here. Okay, 61 expanded is 60 and 1, and 18 expanded is 10 and 8. So now I'm going to do my multiplication inside. 10 times 60 is 600. 10 times 1 is 10. 60 times 8 is 480. And 8 times 1 is 8. So now I just add those up. I get 8 here. 8 plus 1 is 9. 6 plus 4 is 10. So 1,098. Okay. Number 6. Which product is greater than 700 times 50? Select the two correct answers. So since 700 times 50 is a problem I really could do in my head, just because I know that 7 times 5 is 35. And then all I have to do is add how many zeros are in the problem. So 1, 2, 3. And then I'm going to count backwards 3 to put in my comma. 35,000. What I can do is kind of do the same thing for each of my answers and then figure out which one are the two correct answers. So 1,000 times 40 is going to be 1 times 4, and then add 1, 2, 3, 4 zeros. 40,000. 8 times 1 is 8. 1, 2, 3, 4 zeros. 80,000. 6 times 5 is 30. 1, 2, 3 zeros. And 4 times 7 is, 28. And then we have 1, 2, 3 zeros. 1, 2, 3. So what the original question was asking us was which product, which means which answer of the multiplication problems, which product is greater than 700 times 500. So we're comparing all of these answers with 35,000. So we need to check off the ones that are greater or more than. So 40,000 is more than 35,000. 80,000 is more than 35,000. And we can see that 30,000 is less than 35,000 and 28,000 is less than 35,000. So these are our two answers, A and B. All right, so now we're going to look at number 7. Without doing any calculations, compare each product to 73 times 26. Write each expression in the column of the table that best describes it. So ignore what I have here. There is an easy way, or there is a way to estimate and decide which column each of these belongs in, but for the purposes of wanting to make sure that we get this problem right, my suggestion to you is to actually go through and solve each one of these and then put them in the correct columns, okay? So we have less than 73 times 26, equal to 73 times 26, and greater than 73 times 26. So the first thing we want to do is solve 73 times 26, and I'm going to actually do that on a separate piece of paper. Okay. I want to make sure I do this work correctly, so I don't want to squish it onto my paper. So 73 times 26, I'm going to use partial products this time. 6 times 3 is 18. 6 times 70 is 420. 20 times 3 is 60. And 20 times 70 is 1,400. I'm going to add those together. 8, 6, 7, 8, 9, 8, and 1. So now the product that we are comparing all of these to is 1,898. So now we need to know if each one of these is less than, equal to, or greater than 1,898. All right, so basically what I'm suggesting you do is just go through each one of those and figure out where it belongs. So let's start with the first one, which is 35 times 60. This one is 0 times 5, 0, 0 times 30 is 0, so we're going to go right to 60 times 5, 300, and 60 times 30 is 1,800. 0, 0, 8 plus 3 is 11. Carry the 1, and then we have 2,100. So I'm going to write the answer right next to it. And I'm not even going to worry about the chart right now. I'm just going to worry about getting all of these problems solved. So now let's do number 2. 70 times 20. This one, I really don't even need to write out because as I can see, there's 2 zeros here. So all I really need to do is 7 times 2, which is 14, and then add the 2 zeros. And I know that that answer is 1,400 or 1,400. Okay, so I didn't need to write that one out. I could just do that one mentally. Let's look at number 3. 730 times 6. Okay, so 6 times 0 is 0. 6 times 30 is 180. And 6 times 700 is 4,200. So I'm going to add all that up. And remember, you can use the box method for this. I'm just using partial products because I used the box method last time, but it's totally up to you as long as you solve all these problems correctly. So this answer is 4,380. And then we'll move on to number 4. 949 times 2. We have 2 times 9 is 18. 2 times 40 is, 80. This should be blank. And then 2 times 900 is 1,800. Add these together. 8. 8 plus 1 is 9. 8 and 1. Okay, so this one is 1,898. Number 5, we're almost done. See, this problem takes a little bit longer, but if you take your time, then you end up with the correct answer instead of rushing through. So some problems are much shorter and some are much longer, and that's okay. All right, so we're going to do 75 times 23. 3 times 5 is 15. 3 times 70 is 210. 20 times 5 is 100. And 20 times 70 is 1,400. Add these all up. 5, 2, 4, 5, 6, 7. And bring down my 1,725. Okay, so now we have one more to go, and then we're going to start sorting them. So the sixth one is 146. I always like to put the bigger number, and you should too. Put the bigger number on the top and the smaller number underneath when you're setting up your multiplication. All right, so 3 times 6 is 18. 3 times 40 is 120. 3 times 100 is 300. Then we have 10 times 6 is 60. 10 times 40 is 400. And 10 times 100 is 1,000. So I just wanted to count out my zeros first. That's why I did it that way. All right. Here we have 8. It's going to take some time to add up, so make sure you take your time. 6, 7, 8, 9. 4, 5, 6, 7, 8. And bring down my 1. So this one is 1,898. All right, so now that I've done my work, I'm going to take that away, and now I need to sort all of my answers into the columns. Now, remember, you're not taking the answers and putting them into the columns. You are actually going to be pulling each expression into the chart. Okay, so let's start with less than. We know that what we're comparing it to is 1,898, so anything less than that goes into this column. So this is larger, so that doesn't belong there. This is less than 1,898, so 70 times 20 belongs in this column. This is larger than this. This is equal to that. This is less than that, so then we put 75 times 23 into this column. So now we've put both of these where they belong, and we can move on to the rest. This says equal to 73 times 26, and we know that we're comparing it to 1,898, so we need to find the two problems that are equal to this. So right here we have one, which is 2 times 949. So we use that one. And then we have another one that's equal to it, and that is 13 times 146. So those two go into that middle column. And then this last column is greater than this number. And we have 2,100, which is greater than this number. So we can put 35 times 60 in that column. And then we have 4,380 here, which is obviously larger than this. So we can put 730 times 6 into that column. All right, so those are your answers. 2 belong in each column, and those are the correct answers. All right, so we're going to pick up here on number 8. I had to do it on my notebook paper because I kind of messed up on my problem on the study guide, so we're just going to do it here on the line paper. I'm going to use the box method for this one. So in expanded form, 62 is 60 and 2, and 49 is 40 and 9. So 40 times 60 is 2,400. 40 times 2 is 80. 60 times 9 is 540. And 9 times 2 is 18. So I just need to add them all up. I like to add my numbers up from largest to smallest. I find that it makes it easy to line my numbers up, and I don't make silly adding mistakes. So I encourage you to do that as well. We have 8. 4 plus 8 is 12, plus 1 is 13. Carry my 1. 5 plus 4 is 9, plus 1 is 10. Carry my 1, and I get 3. So my answer is 3,038. That is for number 8. So then we can pick up on the study guide with number 9. And number 9 is our first word problem. Okay. An orange grove has 658 trees. There are 14 rows, each with the same number of trees. How many trees are in each row? So we have 14 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now they don't look very even, but let's pretend that they're all even. And all together, there's 658, but there are 14 rows. So we need to know how many trees are in each row. So we need to divide 658 trees altogether into 14 rows. So we need to set up our division problem. Now, you can start with 10. 10 would be an easy place to start, but I know looking at this that 14 times 10 will give me 140, and I'd like to get a little bit closer to 658 than 140, so I'm going to actually start with 20 instead of 10. So I know that 14 times 10 would have been 140, so I can just double that in order to get 14 times 20, and I know that that would be 280. Or you can always just do multiplication off to the side, whatever works for you. But since I know that 14 times 20 is 280, I'm just going to subtract that. I'm writing down my 8. I can't take 8 away from 5, so I'm going to borrow from my 6. I make that 15, and then 15 minus 8 is 7, and then 5 minus 2 is 3. So now I have 378 left. So what I'm going to do is I'm just going to do another 20 because I know that 280 will fit into this without going over. 8 minus 0 is 8. I'm going to borrow here, and 17 minus 8 is 9. And then now I have 14 into 98. So what I can do is I can just go off to the side here and try and do a little bit of multiplication to try and get 14 close to 98 without going over. I'm going to start with 5 just to see where that takes me. 5 times 4 is 20, and then 5 times 1 is 5, plus 2 is 70. 70 is pretty close to 98, but I think I could get even closer. So I'm going to try and add another 14 to 70 and see what I get. I end up with 84. All right, so let me see if I can add another 14. 4 plus 4 is 8. 8 plus 1 is 9. Okay, so I actually got 98. So I started with 5, and then I added another 14 and another 14. So I really did 5, 6, 7. 14 times 7 gave me 98. So I'm going to put a 7 out here, and I know I get 98. And then I have a 0 remainder. So now I need to circle my outside numbers. 20 plus 20 is 40, plus 7 is 47. So this would not be a good enough answer for a word problem. We would have to actually label it. All right. And in this case, I'm just going to look back at my question to see what I should label it. The question's asking us how many trees are in each row. So I'm going to take my answer of 47, and I'm going to label it 47 trees in each row. And that's my answer. All right, let's look at number 10. Oh, another multiplication problem. All right, so I'm going to use a little bit of scrap paper because I don't really have a lot of room here. So let's go ahead and rewrite our problem. 63 times 71. I'm going to do partial products this time. Move this to the center. Okay. 3 times 1 is 3. 1 times 60 is 60. 70 times 3 is 210. 70 times 60 is 4. Sorry, I did not space that correctly. 4,200. See, this is why you don't use pen when you're doing math. All right, we have 3. 6 plus 1 is 7. 2 plus 2 is 4. And then we bring down our 4 and we end up with 4,473. Okay. Let's look at number 11. Okay. Chris is setting up tables for an awards banquet. Each table seats 18 people. What is the fewest number of tables Chris needs to set up for 144 people? So this is another division problem. So we want to divide, we want to divide 144 divided by 18. All right, so if we start with 10, that's going to give us 180, and that's going to be too big. So let's start with something a little bit lower. I know that 180 isn't too far away from 144, but it is a little too big. So I'm going to actually start with 7 and see where that takes me. Off to the side, I'm going to do 18 times 7 because I definitely can't do that in my head. 7 times 8 is 56. 7 times 1 is 7, plus 5 is 12. So I have 126. That will work. Put that in there and subtract. Okay, I'm going to borrow. 14 minus 6 is 8. 3 minus 2 is 1. Oh, now I have 18 left, and I know I can put 18 into 18 one time. I didn't leave myself much room there. Subtract, and I get 0. So then my answer is 8, and it's going to actually be 8 tables will be the answer. But in this case, it is multiple choice, and our answer will be C, 8 tables. Okay. Now if we look at number 12, this is going to be a matching. This is going to be a matching problem, so we are going to solve all of these. And again, like always, I'm going to solve them on paper because I just don't have enough room on this test to do it. And I'm hoping you did the same thing. So let's first go with 750 divided by 15. All right. That's the first problem. I'm going to write the second problem as well. 108 divided by 3. The third problem is 600 divided by 15. And the fourth problem is 800 divided by 16. So now I'm going to just focus on doing the work for all of those. All right, 15 going into 750. Now I could start with 10, but again, it's a little bit low because I know 15 times 10 is only 150. So I'm going to try and go with, I'm going to actually go up to 40 in this one. All right, and so I'm going to do this off to the side. 15 times 40. All right, so 0 times 5 and 0 times 1 is all 0. So I'm just going to start with 40 times 5, which is 200. And then 40 times 10 is 400. And now we have 600. So we put 600 in here, and that's good because it's less than 750. So we subtract, and we end up with 150. Now I should know off the top of my head, how can I fit 15 into 150 without going over? And that is 10. So 10 times 15 is 150, so I end up with a 0 remainder. My answer for this one is 50. Okay, next one. 3 into 108. Now I can do 10 again, but 10 will only give me an answer of 30, and 30 is pretty low, so I'm going to go with 30 as my first choice. 30 times 3 I know is 90, so I'm going to subtract that, and I get 18. How many times can 3 go into 18 without going over? Well, I know off the top of my head that is 6, and I will get 18, so I will end up with no remainder, and my answer will be 36. 15 into 600. Again, we can do 10, but it's still a little low, so I am going to go ahead and try 30. 15 times 30, well, I know that 15 times 3 is going to give me 45, and then I can just add a 0, so 450. Subtract that, and we get 150. How many times can 15 go into 150? 10 times. Add it up, and we get 40. And our last one, 16 into 800. 10's a little too small, so I'm going to try, let's try 50. 16 times 50. So what I'm going to do is I will do a little bit of multiplication on the side here. 0 times 6 and 0 times 1 is 0, so I'm going to skip that side, and I'm just going to go right to 50 times 6 gives me 300, and 50 times 10 gives me 500. Add them together, and I get 800. Oh, I got lucky that time. So we got 800, a remainder of 0, and this answer is 50. Oh, jeez. All right, so when we go back and we look at our different problems, we have here 750 divided by 15, we said was 50. 108 divided by 3, we said was 36. 600 divided by 15, we said was 40. And then 800 divided by 16, we said was 50. Now we already had one answer go to 50, but in this case we have two going to 50. That will not happen on your test, but it just happened on the study guide. But no worries, we just have two answers that both end up in 50. All right, so we're gonna keep on moving along. We have another word problem. Okay. A high school class of 1,540 students poses for a picture on stadium bleachers. There are 35 rows of bleachers, each with the same number of students. How many students are in each row? So we need to do division again. So I'm going to get a little bit of paper here to be able to do my work on. So I need to divide 1,540 by 35. Okay, so if I multiply 35 times 10, I will get 350, and 350 would work, but I know I can probably double that and still be safe, so I'm going to start with 20. 35 times 20, I'm going to do off to the side here. 20 times 5 is 100, and 20 times 30 is 600, so I get 700. And I'm going to put my 700 in here, and I'm going to subtract. Can't take 7 away from 5, so I'm going to borrow. 15 minus 7 is 8, 840. All right, so I'm just going to do 20 again, because I know 20 times 35 is 700, and that will fit in very nicely. 4 minus 0 is 4, 8 minus 7 is 1. Now I have 140. So I can't do 20 again, that's for sure. And if I did 10, I would get 350. So I need to bump down to maybe 5. I'm going to try 5 off to the side to make sure it will fit. 5 times 5 is 25. 5 times 3 is 15, and add my 2, and I get 175. Still a little bit too high, and I'm glad that I did this off to the side so that I didn't mess up my problem. So now I'm going to try 35 times 4. 5 times 4 is 20. Carry my 2. 4 times 3 is 12. Plus 2 is 140. Perfect. So I'm going to put 4 on the outside. 35 times 4, like I just figured out, is 140. So I have no remainder. So my side numbers add up to be 44. And then I'm going to look for my answer, and there it is, 44 students. Perfect. Okay. Number 14, another word problem. Fulton Gardens buys 2,800 flower bulbs. If 40 bulbs can be planted in each flower bed, how many flower beds are needed to plant all the bulbs? So this is another division problem. I'm going to get my scrap paper and set up my division problem. So 2,800 divided by 40. All right, so 40 times 10 will give me 400. I know that's a little bit too low, so I'm going to bump this up to, instead of 10, we'll do 40. Okay, and I know that 4 times 4 is 16, and then we add the 2 zeros, so we would end up with 1,600 or 1,600. Subtract 0, 0, 8 minus 6 is 2. 2 minus 1 is 1. We have 1,200. All right, so what I can do here is cover up 2 of the zeros. How many times would 4 go into 120? And in my head, I know that 4 would go into 120 30 times. So I'm going to try 30. And I'm going to do this off to the side. Well, actually, I could just look at 4 times 3 gives me 12, and then add the 2 zeros, and I get 1,200. So now we have our two side answers give us an answer of 70. So that tells me that it would be 70 flower beds. And I'm going to write my answer in right there. 70 flower beds. All right, number 15. There are 195 cupcakes to be placed into boxes. Each box will hold a dozen cupcakes. How many boxes will be filled? How many cupcakes will be left over? So this tells me that there might be a remainder. So I'm going to do some division here. I know that a dozen is 12. Okay, so I'm taking 195 and dividing it by 12. I'm going to start with 10. Because 12 times 10 is 120, and that's pretty close to 195. So I'll do 120 and subtract 5. 9 minus 2 is 7, so I have 75. 12 into 75, well, I know that 12 times 5 will give me 60, so I'll just start there, subtract, and I end up with 15. So 12 can go into 15 one time. I'll subtract, and I get 3 as a remainder. So I circle my side numbers, add them up, and I get 16 and a remainder of 3. So in this case, my answer would be 16 boxes filled and 3 cupcakes left over. Okay, number 16. Okay, let's move down, there we go. All right, Nick divides 540 baseball cards equally into 15 stacks. How many baseball cards are in each stack? You can use the model. So there's, as you can see in the model, there's 540 in the middle, 15 on one side, and we need to figure out what the other side, what its number would be. So we would multiply these two numbers together to get 540, but in this case, we have the middle number and we have one of the side numbers, so we actually have to divide, which is the opposite of multiplication. So 540 divided by 15. I can do 10, but it's a little bit low, so I'm just going to bump up to 20. to make my problem a little bit shorter. 15 times 10 would have been 150, and I know that 150 plus 150 is 300. So 15 times 20 is 300. I'm going to subtract and get 240. So now I know if I did 20 again, that would be a little bit too high. So I'm just going to go right down to 10 again to make sure that it's not too high. 15 times 10 is 150. Subtract, and I'm going to get 14 minus 5 is 9. Now I have 90. 15 plus 15 I know is 30 because I'm thinking about a clock. 15 minutes and 15 minutes equals a half hour, which is 30 minutes. So if I did 15 plus 15 equals 30, I know that 30 3 times is 90. So I'm going to go with, so really it would look like this if you counted it out. Okay. This is just me trying to do some mental math. So 3 30s equals 90, so that means 1, 2, 3, 4, 5, 6 15s would equal 90. So I'm going to do 6 on the outside, and I know that 15 times 6 gives me 90, and I have no remainder. I'm going to circle my side numbers, add them up. 20 plus 10 is 30, plus 6 is 36. So there are 36 baseball cards in each stack. Great. Number 17. Another division problem. But it does look like we have a little bit of room here, so I'm going to try and do it right on the paper. 625 divided by 47. Okay, so 47 times 10 would give me a number in the 400s, so I'm going to stick with that. 47 times 10, 470. I'm going to subtract, get 5, borrow here. 12 minus 7 is going to give me 5. And then I have 5 minus 4 is 1. So I have 155 left. 47 times 10 will be way too big. So I'm actually just going to try 47 times 2. And I'm going to do that problem out to the side. 7 times 2 is 14. 4 times 2 is 8, plus 1 is 9. Gives me 94. So I'm going to put that in there. Subtract. 15 minus 9 is 6. I have 61 now. So I think I can only fit 47 into 61 one time. So I'll try that. 11 minus 7 is 4. And 5 minus 4 is 1. So we have 14. So I'm going to circle my side numbers because 47 cannot fit into 14. So now we're finished with that part of the problem. 10 plus 2 plus 1 is 13, and then we have a remainder of 14. So the answer for that one is 13, remainder 14. Okay, number 18. We have multiplication now, so let's try the box method. We're going to split 35 into 30 and 5, and then 37 into 30 and 7. 30 times 30 is 900. 30 times 5 is 150. 30 times 7 is 210. And 7 times 5 is 35. I'm going to add them all up. Here, sorry. Don't get distracted by my work up there. Okay, add this all up. 5, 6, 7, 8, 9, 9, 10, 11, 12. So our answer is 1,295. Okay, 19 is the rest of the page. All right, so part of a student solution for 52 times 34 is shown below. So this is another partial products problem, and we have to figure out which step they're missing. So like I did last time, I'm just going to write it out as if I were solving it with partial products. And I would do 4 times 2 first, and then 4 times 50, and then 30 times 2, and then 30 times 50. So I'm just going to cross off the ones that they already have. So they have 2 times 30, they have 50 times 4, and they have 50 times 30. So then 4 times 2 is the one that's missing, and that is letter C. Okay. Number 20 obviously is blank, so we're going to skip that. Go right to 21. Okay, what is the solution for 64 minus 7 plus 5 divided by 2 plus 4? So this is another order of operations problem. I'm going to write it again off to the side because it's a little bit sloppy on here, but I'm going to make sure that I transfer it properly. All right, so I have to remember my order of operations, and that is grouping symbols always come first. So I have grouping symbols here. I have parentheses, so I'm going to do those first. 7 plus 5 is 12. And then I'm going to bring down the rest of my problem. Okay, now I have subtraction, division, and addition, and I know that division and multiplication come before addition and subtraction. So I'm going to do that next. 12 divided by 2, 6. Bring down the rest of my problem. And then now I have subtraction and addition, and when I have those two together, I just need to work from left to right. So 64 minus 6 is 58. And then 58 plus 4 is 62. So my answer is 62. Okay. All right. So let's look at number 22. Okay. On the line, write a numerical expression for the following calculation. Divide the difference between 80 and 20 by 30. So when we're looking at the word difference, that means subtract. Okay, so we want to find the difference between 80 and 20. So we're going to write 80 minus 20 on our page. So we're finished with this part. Divide the difference between 80 and 20 by 30. So we want to divide all of this by 30. So in order to do that, we need to put this in parentheses and write divide by 30. Okay? So that is what the numerical expression should look like for that sentence. Okay, and you don't actually have to solve it, you just need to write the expression. All right, so let's look at 23. Okay, which product is less than 36 times 69? So we want to look for anything that's less than. So what we can do is actually solve the problem. 36 times 69, 9 times 6, 54, 9 times 30, 270, 60 times 6, 360, and 60 times 30, 1,800. 4, we have 5 plus 7 is 12 plus 6 is 18. 8, 9, 10, 11, 12, 13, 14. So this is actually 2,484. So we want to find anything that's less than that. I'm going to first start with the ones I can do in my head. 70 times 40 I can do in my head because I know 7 times 4 is 28, and then I add my 2 zeros. 4 times 9 is 36. And then I add my 2 zeros. 35 times 100 is easy because I just take 35 and I add 2 zeros because 35 times 1 is 35. Add the 2 zeros. And this one, 60 times 36, I'm going to actually write out. 36 times 60. I'm going to put, we have a 0 here and zeros here. So I'm going to do 60 times 6, 360, 60 times 30, 1,800, 8, 9, 10, 11. So this one is 2,160. So I want to know which product is less than 2,484, and it looks like the only one that is less than is A. All right. Okay, so let's just focus on the top part of this problem. 24 is a two-part problem. Morgan is reading a 236-page book. The table shows 3 different plans to finish the book. So plan A says to read 10 pages each day, and that will take 24 days to complete. Plan B says to read 20 pages per day, and we don't know how many days that will take to complete yet. And plan C says to read 30 pages per day, and that will only take 8 days to complete. So as you can see, the more pages she reads per day, the less days it'll take for her to read that book. So part A, using plan B, how many days will it take Morgan to finish her book? So what we need to do is we need to divide her 236-page book into 20 pages. All right, so I'm going to get my scrap paper out to solve this. Okay, so a 236-page book divided by 20 days. I'm going to start with 10. 20 times 10 is 200, and I end up with 36. 20 can go into 36 one time, and I end up with 16. So these two tell me the answer is 11, remainder 6. So that means, can we have 11 remainder 6 days? No, it would actually take her 12 days then to finish the book. Okay, because you can't have a remainder when it comes to days. And then we're going to look at part B, which explains how to find the number of days it will take Morgan to finish her book using plan B. Choose the 2 correct answers. Okay, let's look at the very first. Let's do it step by step. So we'll figure out which ones do explain and which ones really don't. So multiply 20 times 11 to get 220, which is not enough days. So multiply 20 times 12 to get 240, which is enough days. So what they're talking about is multiplying 20 pages per day times 11 days. If you multiply reading 20 pages per day times 11 days, you get only 220. And that is just not... Here, let me pull this down a little bit. Okay. 20 pages per day times 11 days only gives you 220 pages when her book is 236 pages, so that's not enough. If you multiply 20 times 12 days, 20 days times 12 pages per day, you get 240, which is enough days. So that actually does work. So we're going to check that one off. Okay, next one. Since 20 pages is halfway between 10 and 30 pages, the number of days must be halfway between 24 and 80 pages. And that's not true, because we are talking about a 236 page book, and these numbers don't all go into 236 evenly, so that middle number is not necessarily halfway between these two. Okay. Since 10 pages are added each day from plan A to plan B, 10 days must be subtracted from the number of days needed in plan A. So they're saying that 24 days were needed for 10 pages per day, so all you have to do is subtract 10 here. And that's not true, because they really, the number of days, if you subtracted 10, you would get 14, and then if you subtracted 10 again, you would have 4, and that doesn't match up with plan C. So that one doesn't work either. If we divide 236, which is the number of pages in her book, divided by 20 to get 11, remainder 16, you interpret the remainder to require one more day. And that's exactly what we did. So we know that that is true. So the answer is A and D. All right, last problem. Jessica, Elizabeth, Reba, and Chloe are playing a card game. Each hand is made up of 4 numbers and 3 symbols. The winner is the person who uses the cards to make the expression with the greatest solution. The first hand consists of the following cards. Which girl's expression had the greatest solution? So, what we can do is go ahead and solve every single one of these, which will probably be the easiest way to tell who has the highest solution. So I'm just going to go ahead and do Jessica's first. She had 24 times 4 divided by 2 minus 6. So I'm going to do my grouping symbols first. Bring the rest of my problem down. And then I'm going to do multiplication before I do subtraction. 24 times 2 is 48 minus 6 is 42. So Jessica had 42. Not bad. Elizabeth did this. So 4 times 6, since we have 2 pairs of grouping symbols, it doesn't really matter which one you do first. 4 times 6, only because there is a operation sign in the middle, so that's keeping them separated. So if you do them both, they're both going to end up on the opposite side of the subtraction side, so it doesn't matter which one you do first. 4 times 6 is 24, and 24 divided by 2 is 12. You're going to subtract 24 minus 12, and you get 12. I don't know why Elizabeth thought that would be the highest one, but it's not. Okay, here we have brackets, so we have to be careful when we're transferring this onto our paper. Okay, so we're going to start, remember, from the inside out when you have 2 pairs of grouping symbols inside each other. 24 minus 6 is 18. And then I'm going to bring down my bracket. 18 divided by 2 is 9 times 4 is 36. So that's 36, but still not the greatest one. Alright, so then we have to do Chloe's as last. Chloe is D, and she did 24 times 4 in parentheses, divided by 6 minus 2 in parentheses. Alright, so 24 minus 4, that is a pretty big number. So we have 16. 4 times 4 is 16, so I brought down the 6. I'm going to carry the 1. And then 4 times 2 is 8, plus 1 is 9. 24 times 4 is 96. And then we're going to bring our division sign down, and then 6 minus 2 is 4. 96 divided by 4, I'm going to do that off to the side here. 4 times 10, 40. I'll subtract, get 56, so I can do 4 times 10 again. Subtract, and I get 16, and I know 4 can go into 16 4 times. So 16, and then I get an answer of 24. So my answer down here is 24. So that tells me that if we want to know who had the greatest solution, it would be Jessica, letter A.